Dear students, you are welcome to the knowledge series on segmentation and paging. Now here in this slide, let me explain about the difference between the segmentation and paging. Now segmentation, as the name indicates, that it is the method in which the process is divided into different parts and then put into the main memory for the CPU to access. Now, as the statement, it shows that the process is being divided into different parts. Let's take an example. This is a program in C. So this program in C is been having different sections, like a main sections, having a addition sections, subtraction sections, square root, stack, subrouting. That means various section wise the program is being divided, and this program, instead of putting in the memory at a one particular point, it is being splitted and put into the memory in a different locations. So when the program is being put in different locations, automatically the CPU will try to fetch these particular programs, and thereby it will execute. It is not possible that you in the every programs that is being written and it is being directly placed at one particular locations, because of the dynamic allocations of the memory structures. So that's why in the segmentations what is done is that the program structure is being put into the memories in a different allocations. Now you can see that S1 is here, S2 is placed here, S3 is placed here, and after S1 is S4, after S3 is S5, after S2 is S6. Like that, in a randomized way, the individual function is being put across in a different blocks. So segmentation work in a user perspective. So based on the program structures, how you write the program, and the placement of the blocks will be in the memory accordingly. If the complexity of the program structure is increased, automatically these blocks will be also getting placed in the memory in a various locations, and thereby if the locations of the program functions or a blocks is being placed in a randomized way, automatically we know that to fetch that one from that particular memory for the CPU, it will take its time, because memory will search for the S1, then it will look for the S2 is here or not, then it will look for the S2 is here or not, like that. And once it is located, the S2 is here, then it will be fetching it back for the executions. So that's why in the segmentations the process is being divided into various parts and placed in different locations. On the other hand, the paging. In the paging, the process is divided into equal parts and put into the main memory. It simply divides the program into equal segment and same in the save in the main memory for the CPU to access. That means, if suppose this is the program C is there, the entire program is divided into equal blocks. Maybe that the part of this one may be here. If this size is more and this size is less, then suppose if you add together, then if you divide into two parts, sometimes this may be here. So like that, a add function is taken, and add function is been divided into F3 and F4, and it is being placed in a randomized ways in the memory. That means it simply divides the program into equal segments and save in the main memory for the CPU access. Now suppose in the paging, if it is being done like that, what is happening? Addition will not take place first for the complex function. Suppose you want to add some function, and there is a blocks, like a 10 blocks are there, and 10 blocks is a randomized way. Suppose 2 plus 3, let us take it. So 2 is here and 3 is here. I'm just giving an example, and if the 2 has to come first and then 3, then first CPU will look for the where is the address of that 2, and and after that it will go back to the address of the 3 here, and then it will go for addition. That is what it specifies. Addition will not take place fast because for a complex function, if a complexity increases, then it will take more time. Page fault will arise. Sometime what happens if the complexity arises, suppose F3 is placed somewhere else, and it has to locate. So sometime CPU will take its time, and if the time for retrieval, if it is increased automatically, page fault may also arise. That's what. Saving in a non-contiguous way will cause error and delay. Since it is now here you see F4 is here because this block is equal to this block, and there is a free space is there, and after that F3 is there. So this is a non-contiguous manners because it is not a contiguous way. So since it is not a contiguous way, or in a sequential way, or contiguous way, so there may be chances that error may occur or a delay will be taking for the CPU to retrieve. Paging work on a function divides versus point of saving location. That means paging basically divides the function into equal parts, and also it based on where it is being positions or where it has been saved. Now there is a problem in the paging. Paging don't bother where the program starts and ends. It simply divides the program into pages. That's what exactly, because it whether your program starts or the end, the starting point and ending point is not the main criteria. Now here you see F3 and F4. F3 is here and F4 is here. Actually F3 starts after that F4. So here F3 has to start since it is positions. So that's why it is saying that it is randomized way. So there is no particular structure for placing this one except the block size is being considered. Now let's see the comparison between the paging and segmentations. A paging is a non-contiguous memory locations. Now here you see that in the case of paging, the block structures size will be same, but it is a non-contiguous. On the other hand, the segmentation is also non-contiguous memory allocations, but the memory size will be varying. This size is smaller as compared to this one. This size is bigger as compared to this. That's why here it is a variable size. Here is a fixed size. Paging divides the program into fixed size pages. Segmentation program into variable size, as I explained. Operating system is responsible for paging. In this case, the operating system is responsible. Whereas this one is a user or a compiler is responsible for the segmentations, because based on the program structures it is being placed. Paging is faster because in this case the retrieval is faster as compared to the because of the divide and fixed structure is there. Whereas segmentation is slower because of the dynamic block structures. Paging is close to the operating systems because operating system is responsible. That's why paging is closer. Now here in this case segmentation is close to the users because of the program structures. And the program structure is the basic criterion for the segmentation. It suffers from the internal fragmentations. Now here if you see this one, this block is used, this is unused. Suppose if the block size is smaller, and if the memory block is fixed, and if the smaller size is used, even if the memory is having a larger size, so that unused structures will not be will be the condition for the internal fragmentations. Whereas in the case of non-dynamic situations, the external fragmentation comes because these unused things are non-contiguous manner, and sometimes it happens that the unused space may not be meeting the needs of the process. So there may also occur the situations with respect to the external fragmentation. So since there is an internal fragmentation, in this case there is no external fragmentations comes because of the space availability. Now here in this case the internal fragmentations comes because the unused space cannot be reused. The Logical address is divided into page number and page offset in the case of a paging, because on the secondary memory structure. The logical address in this case with respect to the segment number and segment offset. Here it is page number and page offset. Here it is segment number and segment offset. Now paging table is used for to maintain a page information. As I explained in my earlier video, the paging and that is the logical address space and the physical address space between this table is being maintained, so that the paging table is used to maintain page information. Now here segment table is kept keep the account of all segment informations. Page table entry have frame number and some flags bits to represent about the pages, because page table has to map between the logical address to the physical address. So that's why there should be a flag for the to see that page table and the frame entry is being assigned appropriately. Segment table has a segment and some protective bits. So that is the case with respect to the segment table. So there, these are the comparisons between the paging and segmentation, and this is one of the important university expected questions also. Thank you.